My name is Andrew Moore. I am the head of Google Cloud AI. I've spent my whole career passionate about artificial intelligence through the bad times and through the good times. And of course, we're now in a very exciting period where artificial intelligence is not science fiction and it's not a research project. But, and you're going to see this theme of the but very much during this session, it is still the case that those of us in the industry have to work very carefully to make sure that artificial intelligence is deployed successfully. And what I really mean here is if I look at an AI tool across the spectrum, or if I look at an AI solutions organization, I am not super interested in counting the number of people using that tool or using the services of that organization. The one thing that matters is the number of successful deployments of artificial intelligence. And during the phases of an AI project, you will usually begin with careful proof of concept work, lots of exploratory stuff. If you know what you're doing, you will always be working with people who can represent or speak for the end users and the final customers, but you'll be in the proof of concept stage. The danger and the place where, for me, it's like watching baby turtles trying to get across the beach, is all the terrible things that can happen to an AI project from that moment of passing through the proof of concept through to being a deployed solution where an organization or a set of users or a government are delighted by what artificial intelligence is doing. So for us at Google, this has absolutely been our obsession, especially over the last 12 months, is making sure that we're always asking the question, not what is exciting and new necessarily, but what is going to make sure that the things people want to do with AI actually end up sitting there in reality. And that's why my third bullet point here is so important. I really don't want it to be a big deal when an AI deployment goes live. We are on a mission to routinize this process. The most important part of any AI project are, of course, the people working on it. And the place where I've been involved in emergency AI projects, and I've been involved in very slow, thoughtful, long-term AI projects. And in all those cases, you have to make sure the builders, the folks who are developing what you're doing, have all the tools at their disposal to do what they're good at, which is being creative with the math and the numbers and the data manipulation needed to provide the solution. And so when you look at the big theme of what we talked about this morning in the keynote session, you'll see that the things that we're putting in place are the things which remove the friction from being able to go from a proof of concept to a safe, reliable, fully deployed AI system. And for the benefit of many builders, it's a question of making it so that as they're incrementally improving what they're doing, they can continue to work in an agile fashion rather than a waterfall fashion, using tools to tweak and repeat and make sure that the pipeline that they made 5 weeks ago is maintainable and understandable for when they next tweak it. So this, I, with confidence, believe is the major frontier in artificial intelligence, and we all have to be really thoughtful now about making sure that AI gets deployed. That's not to say that there aren't amazing new things coming down the pipeline. I am very confident that over the next 2 or 3 years, major new bits of AI will be emerging for us to routinize as well. Things like causal network learning, or computer vision algorithms which are based on single photons and allow you to do things like look around corners or look through flesh. Work on making AI more explainable and understandable. And then other really interesting things which are just moving out of academia to do with applying machine learning to automatically improve code and improve algorithms of developers. So while I say my job is to make AI boring, I don't want you to worry that the whole discipline is going to be boring. It's just that there's the new stuff coming up, and our role, our most important job for the economy of the world, is to make it so that what's already available actually gets deployed and used. So today we have 3 remarkable speakers, all from remarkable organizations, who are going to talk about different parts of this puzzle. And the first I'm pleased to introduce is Jay Chopra from Cruise, GM's self-driving car division, who's going to talk about this question of how we empower creative builders. Jay.
Thanks, Andrew. All right, thanks so much, Andrew. It's great to be here. So I'm going to be talking today about Cruise's end-to-end machine learning platform, and to touch on some of the points that Andrew mentioned, how we're able to empower our creative builders to ultimately get models into production into a safe way. So at Cruise, we're building the most advanced self-driving vehicles to safely connect people with places, things, and experiences that they care about. As Andrew mentioned, AI is at the core of our product, our autonomous vehicle itself. And so machine learning has become a critical component to support in Cruise's infrastructure. Machine learning at Cruise involves feature engineering, annotation, training, and validation that comes from our sensors that come from our vehicles that travel around San Francisco every day. This includes LiDAR, video, audio, and radar sensors that enable our robot to perceive the world around it in great detail. This creates an enormous infrastructure challenge, as not only do we have the sheer scale of large data sets that we need to process quickly, but we also have a diverse set of machine learning use cases, from statistical modeling with scikit models to sophisticated cutting-edge models using deep learning using TensorFlow. From research and experimental models to thoroughly tested low latency production models that are deployed on our vehicle. So how do we support this? I'm going to provide you a brief introduction and walking through the end-to-end steps of Cruise's machine learning platform. And this covers 3 broad areas: data processing, experimentation, and finally, deployment. Throughout, I'll cover where we've used open source, GCP, and our own custom inbuilt solutions to supercharge machine learning development to empower our creative builders that we have at Cruise. So let's start with data processing. At Cruise, we love open source. Apache Beam and Spark have become a staple in most of our machine learning workloads. By extending Beam, we've created our own toolkit that we use internally that's powering autonomous vehicle software development, and we call this Terra. Under the hood, Terra is portable. It allows you to essentially abstract over compute and scale elastically using GCP's data flow, as well as Dataproc, which under the hood uses Spark, and our custom compute engines that we have at Cruise. So in this way, a local developer can take a pipeline and scale it up using the power of the cloud, elastically, seamlessly, with a great experience. Not only that, but we can take an experimental pipeline and turn that into a production pipeline across batch and stream really easily. Another design goal of Terra is the concept of reuse. At Cruise, we think of the building blocks of each of these machine learning pipelines as having a network effect for teams to be able to collaborate and work together. So with Terra, you can pull in the building blocks of data processing at Cruise, be it validation logic, feature extraction logic, ways to synchronize time series data really easily and really effectively. You can also publish these to the platform and have other teams comment, reuse, and share those as well. So how do we store all of this really rich, heterogeneous, structured and unstructured data? At Cruise, we've built our own federated data store. which allows us to track the end-to-end workflow in a way that's both traceable and reproducible for safety. We can store all of the operational metadata that goes into each machine learning pipeline, such as data frames, as well as binaries, such as point clouds, audio, and the sensor data that I was talking about earlier. Under the hood, it uses a mix of Cloud SQL, BigQuery, Bigtable, GCS, and a container registry to store the building blocks of machine learning. This enables traceability and reproducibility as first-class citizens on our platform. So after preparing the data, the next step in the workflow is to train your model. And as you could probably tell, training a model, especially in deep learning models, using really large-scale data sets can be both expensive on the infrastructure side and also expensive for productivity. So at Cruise, we've developed our own frameworks that supercharge deep learning experimentation. And these plug seamlessly into our platform stack, allowing us to scale in various different methods, be it just distributed GPU compute, TPUs, and more. We're also able to leverage open source frameworks such as Horvath and TensorFlow's distributed methods to scale out really quickly. So the next stage is the most important stage, and this is deployment. And one of the areas that we're continuing to invest in Cruise is understanding the interpretability and diagnosis of machine learning. By having efficient data access patterns, we're able to slice over a rich set of evaluation metrics, so machine learning teams can root cause model performance efficiently and launch a new experiment based on those learnings. We can do this every day. Our engineering productivity and design teams have recently open sourced some of our visualization tooling, which you can check out on GitHub now, which allow machine learning teams to build component libraries that are agnostic both to model and data type. So this really ties back to what's unique about Cruise. Due to our deep integration that we have with General Motors, with any new given iteration of our vehicle, we can have new sensors that require new training and new deployments. Using our platform, we can safely react quickly and deploy. So as you can tell, there are a few emerging design themes throughout our platform. And at Cruise, we think that we believe that the standardization of infrastructure while retaining the flexibility for machine learning practitioners to share their diverse set of knowledge, their unique skills and experiences leads to a faster rate of progress for us to achieve our mission. So thanks, Andrew, and to the Google Cloud team for allowing me to present this to you today. We really appreciate the opportunity. Thanks.
Thanks very much, Jay. I think this demonstrates how very high-performing teams with very difficult analytics who still need to move at speeds to keep getting better models every week need to build up frameworks to maintain that productivity. And I have been in projects where we haven't had that tooling and we keep having to rewrite big lumps of stuff, and I personally would see a 2 to 5 times slowdown if you don't have that experimentation platform correct. So our next speaker is from one of the hottest recent arrivals on the artificial intelligence scheme, Singh from UiPath, who's going to be talking about deployment of AI in a way where everyone's able to use it. PD.
Thanks, Andrew. Andrew, thanks. We really appreciate the partnership that we have going on with Google. So let me take you through a bunch of different problems that you grapple with once you start thinking about deploying AI and machine learning in an enterprise. Let me ask you a question. I want to keep this a little bit more interactive. A show of hands. How many of you have actually built machine learning models? Great. Now, how many of you have actually put those models in production in an enterprise where people are really using those insights and you're closing the feedback loop? Great. So This is an audience which understands what it takes to deploy the models in an enterprise. And now a show of hands, tell me how many of you like that last mile, which is once you've developed the models and once you've tested them properly in your own sandbox and in your own tools, deploying those models, having them talk to your line of business applications or end user applications. How many of you like that part of the job? Yeah, I guess so. So it's definitely a small group of people. You guys are definitely exceptions there. But let me tell you what we see in the real world. All the analysts and including some of the people who are here right now attending this session, we all know that AI market is a big market, right? It's going to be a $48 to $50 billion market by 2021. But when you start looking at how many of these workloads have actually been deployed in real-world use cases in enterprises, it's only 4% of the CIOs who say they have something in production. And if you look at a typical AI lifecycle of any model that you're trying to develop and deploy, it looks something like this. Firstly, you have to do a bunch of data storage and exploration. Then you do something for ETL, transforming the data, pre-processing it, featureizing it, doing the feature selection. And then you start building your model and doing the training. And then you actually deploy the model. But what does deploying the model actually mean? And we think that AI right now lacks the delivery mechanisms, the really fast delivery mechanisms for you to be able to deploy these models quickly in production settings. So at UiPath, we are an RPA company. And I can tell you, what if we gave you access to a tool with which you could deploy these AI models at the fraction of a cost of the resources that you employ right now to deploy these models, and in a fraction of time, like within 30 seconds. We'll give you a live demo of that. But what we mean is, how many of you know what RPA is? Great. So this whole audience already knows a lot about it. But if you look at a basic RPA system, it's a logistic-based system which automates a lot of your rule-based tasks. And you can do these automations by automation of the UI and the front-end apps that you use in your enterprises. And it's a very low-code way of automating your workflow designs. Now, when you start combining AI with RPA, this is the future of taking your AI models and deploying them quickly in an enterprise. So we know AI is really good at problems where cognitive functions are involved, where you need to do complex things, where you need to do continuous model improvement, like Andrew was talking about. How do you close that feedback loop? And you have to do things like understand unstructured data sources. For example, things that are coming out of scans, of invoices, receipts, whatever you have made. But if you look at the RPA, as we talked about, it automates just your repetitive tasks in a low-code way where it understands very structured data elements. Today, we are unveiling a new service from UiPath that we call the AI Fabric. We are the first RPA company in the world that will natively support putting machine learning models straight into an RPA workflow. A lot of you who have worked with RPA and tried to combine RPA with AI, you would have seen things which let you do Python inlining and stuff. But we are talking about production-grade ML models, like TensorFlow models, any of the models that have been developed using any toolkit, being able to put those models up into the cloud or on-prem, and then be able to improve and basically include that model in your RPA workflows. So at UiPath, we call these things AI skills. Think of skills as models that you can easily deploy, but these are full packages, including libraries and all the dependencies that you can include. So we work with a lot of technology partners. We work with a lot of customers because what we feel is there's a lack of a technology platform right now where your partners your customers can bring in their own models into these enterprise workflows easily. And that's what we want to enable. And so we're working closely with Google Cloud, thanks to our partners over here, which will let you manage, deploy, improve, and build these models really, really easily. And then you can use RPA for your use cases that are prevalent across the enterprises. We have a session going on tomorrow detailing how we do invoice processing using some of these technologies. But you can do things like insurance claims processing, contact center scenarios. But we are an open platform which is built on top of Kubernetes and Kubeflow. And we want to embrace this hybrid and open architecture. Having said that, let me have Anton give us a demo of the AI fabric. Thank you, Anton.
OK. So this is our orchestrator environment. This is where we keep all of our automation components. We have a new section called ML Skills. What I'm going to do really quickly is upload a model that's been trained for the purposes of email classification for a bank who has a lot of emails coming into a generic email. So let me see, email class, input type, JSON, test, language. So this model has been trained by our very own data scientist, Jeremy Taderi. But we want to actually use that in a real-world setting. So the model's now uploaded onto GCP, onto Google Cloud's blob storage. Now we're going to deploy the model. So what's going to happen is that model, that zip file is going to take the model, containerize it, expose an endpoint via Kubeflow, serve it via Selden Core, and now that model is available to any user connected to this orchestrator tenant. So the use case is a bank has all of these emails coming into this general email account. They can be complaints, they can be queries, and we're going to categorize these so they can be sent to the various teams that actually deal with these problems, these use cases. We have this activity called ML Skills. I have it already in my workflow. I can choose the deployed model. I click OK. I'm passing an input and exposing an output to the following activity. And now I'm going to run. And what's going to happen is our robot, and it's just this little executable on the bottom of the screen, is going to take the body of these emails, categorize them. Oh, my goodness.
So while Anton is showing this stuff, this use case, think of a large bank, which is getting thousands of emails every day. And we are working with a customer of ours, which is a bank, where they've employed 60 people just to triage these emails. And so as the emails come in, you can build an email classification model. You can use any technology for that, LSTMs or just the basic NLP models. But having that model go in through your mailbox, look through all those emails, classify them, put them in specific folders. So for example, over here, this model is going to route those emails to the very specific departments where they need to go. So for example, if it's one of the customer service emails or mortgage departments or fraud detection, and this model can be easily deployed, as Anton was showing, within 30 seconds, and it'll go through your emails and categorize them pretty easily. So these are the kind of use cases that we are going after, where we are making the lives of data scientists and AI practitioners much easy, where you can just take these models and quickly deploy them in enterprise workloads easily as possible.
It's working. It's working.
Very cool.
So what's happening here is they're moving into these folders. As you can see, one by one, taking each email and moving into the folders, and automatically can be routed to whatever team actually deals with it. So we had one reference customer, PD, 60 people who just do triage on these generic email accounts, and we've just automated it in a few quick minutes.
Yep. That's pretty cool. Thank you, Anton. With that, I hand it over to Andrew.
So when I was growing up, this kind of thing was totally science fiction. It's really nice to see how it's become part of the reality of development of AI. So now I'm very pleased to introduce one of the experts in the general themes of AI development, someone I turn to for the last few years to have understood what's happening next and what the big overall themes are. So it's with great pleasure I hand the mic over to Mike Gualtieri.
Thank you. Hi, everyone. Great to be here at Google Next. So my name is Mike Gualtieri, principal researcher at Forrester, and I cover artificial intelligence technologies, mostly machine learning. So through our research, I talked to a lot of companies, a lot of data science teams, and so what I want to present to you now is some tips, some advice that we've learned through our research that may help you implement AI projects. So our general belief is that AI is a force for good. It's going to make healthcare cheaper. It's going to make more hyper-personalized customer experiences. It's going to affect essentially every aspect of society in positive ways. There are some risks, but generally it's a force for good. And we believe it's going to be the enterprises that do it, because it's the enterprises that have the rich data. It's the enterprises that will make this happen. Now, for the past 3 years, we've been asking companies how much are they adopting AI, and we don't define what it is, but you can see the number of companies saying no is on the decline. The number of companies saying yes is going up. We believe in 3 to 5 years, it'll be about 100% of the companies. Now, this doesn't mean they're implementing all that they can. They may just be dabbling. So here are some of the advice. So the first thing is to choose multiple high ROI use cases. It's pretty obvious to choose a high ROI use case, but sometimes we see companies choosing toy use cases. Now the reason why it's multiple is because machine learning doesn't always work. You might not have the signal and the data. So what we've seen is we've seen companies sit around a table. They decide that this use case would be fabulous. They work on it for 6 months. The signal isn't in the data. So you have to think about these projects a little bit more like a VC invests in companies. They believe that the 10 companies they invest in will be successful, but statistically 3 will. So work on multiple projects. We believe there are thousands of use cases. You can find them in customer journeys. You can find them in business processes. Few examples: an airline reduced their catering by 12%. Companies are using it, obviously, for e-commerce. They're using it to provide personalized consultation and advice, hyper-personalizing the in-store experiences. Deep learning is being used to detect disease. And one railroad saved $70 million with just one model by predicting slowdowns so that those slowdowns could be avoided. So anything in your business that you can predict is a potential use case. And if you walk the business through this and you don't talk about AI and you don't talk about machine learning, but you talk about prediction, all of a sudden the ideas start to flow. So important to work on those multiple use cases. Now the second thing, and if you're a data scientist, you already know this, you have to insist on access to the data. Because again, algorithms get all the press, but it's really the data that matters. And it's also true in machine learning. Garbage in, garbage out is absolutely true in this as well. The problem is you don't know what data you need. So you have to get a lot more. And it's not about the size, it's about the right data. The good news is that organizations have dozens, hundreds, sometimes thousands of applications that all originate data. So there's plenty of data there, but you're going to need, it's a big prerequisite to even doing this in the first place. If you think who's going to dominate AI, who's going to dominate AI? It's the enterprises in their industry, because AI is completely dependent on good data. And it's you and your enterprises that have that data. And this is just a few of the examples. So data is the fuel that will drive those machine learning projects. But if you don't have the signal in the data, you're not going to have the use case, which brings us back to the other point, which is you need those use cases. You need multiple use cases. As I said, everyone talks about algorithms. It gets all the press, but it's the data that really matters. The other thing is, this was alluded to earlier, that AI, you may build a model, but getting it deployed is a whole other job. So data science is really about how can prediction be used in a business, but it impacts those business processes, obviously. But for some reason, enterprises think data science is some secret thing that just happens over here, and when the data scientist comes out a model, then you worry about it. Instead, you have to worry about it in advance. It impacts business processes, it impacts that customer experience, and it impacts application design and development, because a lot of these models are going to be manifested within an application, or they could be manifested within an RPA tool like UiPath. So foster that collaboration. This is just like developing new software early on, so that there's not a big lag time between when the model is trained and is deemed accurate enough and when it actually gets used in the business. And then another important aspect here that I think a lot of companies overlook is that those models have to stay fresh at scale. Now, models are probabilistic. They are not absolute. That means they're going to have false positives. They're going to have false negatives. They're probabilistic. Now, when they're trained historically, and there's some degree of accuracy, but that model performance is likely to decay over time. It was trained on historical data that represents an environment. If that environment changes, then the model has to change as well. But if it stays in production forever, it's going to decay in performance, and then you're going to start getting negative business value. That is opposed to code. When you develop code, when you write some Python or Java code and you deploy it, it's going to run that way forever. Might have bugs, but it's going to run that way forever. Machine learning models are different. So you need to retrain them, and the business will probably say, I want them to be more accurate, so you may even want to remodel them as well. There's an implication here. When you deploy one model, okay, that's no problem. You can use like swivel chair collaboration to get this sort of stuff done. But when you're doing millions of models, when you're doing hundreds of use cases or 1,000 use cases, you need a system to be able to do this. And whatever infrastructure you used to train that model, you're going to need that in perpetuity. Not continuously, but every time you need to retrain the model, you're going to need the infrastructure to train that model. So what happens when you have 50 models, 100 models? This is why cloud companies love AI workloads, right? Because you're going to need that infrastructure for a long time. There's also this concept that's involved in this handoff between the training and the operations of that model. We call it the ML ops engineer. Sometimes we call it the model ops engineer. But there's all of these roles that need to get involved. And it's very different than DevOps and the delivering of code, because models, again, have to be trained and retrained. And then finally, keep humans in the loop. I guess this sounds pretty obvious, but AI models are probabilistic, right? So they're not perfect. They are a lot like us. You have to be able to explain your AI, and I'm sure there's plenty of talks here on explainability and anti-bias techniques and so forth, but you have to be able to explain how that's working. And there's multiple methods out there. There's Lime and Shapley's and more techniques emerging in the research, but you have to be able to explain it. But here's the most important thing. And this is important not necessarily for you, but it's important to be able to say to your business sponsor, you don't have to do what the model tells you to do, right? Data scientists are obsessed with accuracy, and you could overcome that accuracy simply by deploying the model. And if the model tells you to do something that you don't want to do, you can just put code that says, if the model says do this, don't do it. Right? So this is a way to get models, AI, adopted by telling businesses that you can surround these with rules. I guess in the 80s you might call that expert systems. But you can surround a model with rules that can negate some of the effects of an accuracy model. Typical example, there's a model, it makes loan decisions, and you could simply say, if it wants to grant $1 million loan, we're not going to do that. We're going to route it to a human. So this is another important point. So artificial intelligence is not a science project. It's not a POC. It's something that every enterprise needs to do, whether they build or buy. If you're large enough, you're probably going to do both. And that's why we think it's the fastest growing workload on the planet. Thank you.
Thank you so much, Mike. And there's so much more to dig into here. What we're going to do now is Mike and I are going to sit on stage, and I'm going to ask a few questions to follow up on some of the themes that have come out of this session. So please pull up a chair.
Okay. I'll take this one.
Let's get some votes from the audience. Should we be sitting on these, or should we have Mike on that chair and me on that chair? All right, we'll stick with the seats for now. All right, so I do still find plenty of customers who really have not had the opportunity to get educated in machine learning and AI, who come to me with the message that you're warning against. I've got lots of data. Here, Andrew, let me give you a bag of money. Go and find value in the data.
Yeah.
How do you think I should respond to those kinds of things? How can we help those folks come to the good side?
Oh, the ones that take, I'm sorry.
Folks who actually don't really know anything other than that they've got data.
Yeah. Well, I mean, so I end up having to explain that a lot, right? And usually, many people think they freeze when they hear AI. And so one of the things we do is we say, look, there's two types of AI. There's pure AI, and that's Ava and Ex Machina, or any other sci-fi movie you would have seen. That's not what we're talking about. We're not on the precipice of that. In fact, there was an academic study out 2 years ago where they polled AI researchers, and they said, hey, when do you think we'll reach pure AI, full automation of all human labor? And so it was, the earliest was like 50 years from now. The largest was like over 125 years, over 200 years. The median was like 125 years. That's not where we're at. So we explain there's pragmatic AI. Pragmatic AI is narrow in scope, like Google winning the game of Go, or IBM winning Jeopardy. But those were specifically trained for the task. It exceeded human intelligence, but Google, IBM, you can't snap your finger. It's not generalized, because if it was, then we could turn it into a doctor instantly, right? So I think the first step is to understand that pragmatic AI is much narrower in scope, and it's essentially about prediction. And when you start asking people about what they would like to predict, now you start getting use cases.
Yes, that makes perfect sense.
Yeah.
One thing which I find really encouraging looking at this audience is there's a diversity of people in this audience. It's not just all coming from one socioeconomic group or any kind of one demographic. So I see that as an important trend, and I believe there has been some business analysis of how you're more likely to have a successful AI project if you've got folks from many backgrounds.
Well, yeah, and I think that's and I think that's kind of what I was saying, is that it's a team sport, right?
Yep.
Because you need to involve the business just like you would involve any project, business and developers. But one of the skill that a developer or data scientist need is the ability to explain this stuff, but not in, like, people say, oh, how can I learn about machine learning? And they're like, I'm going to go to Coursera. No, that's like the worst thing you could do, because that's going to, if you're a business person, because that's going to go into how it works. It's going to go into the nitty gritty. And so I think sometimes data scientists will explain it at too technical a level for business people to understand it. But you need all those ideas in. And people sometimes say, well, a data scientist has to be a unicorn. Not really. I don't believe that, actually, because if they understand a business domain, it's because they have to understand, they have to have hypotheses about what will create value in the business, but you can ask the business and the subject matter experts that as well.
Yep, I think that really helps.
Yeah.
I now personally believe that the majority of AI deployments I'm asked to help with, the real question is change management and how an organization is going to operate differently.
Yeah.
And the technology is important, but it's the secondary part of all of this.
Yeah, and I think I've talked to a lot of companies, they're asking questions about ethics of AI, false positives and the impact of that. So there's a whole other set of issues that have nothing to do with technology that have to be injected into the change management process as well.
Yes, I 3/4 agree. They're nothing to do with technology. I actually am encouraging genius grad students in these areas to really look at the mathematics behind these questions as well, because I am optimistic that we can, in some cases such as privacy-preserving machine learning, where you want to learn from a whole bunch of PII data, but without anyone having to reveal their own PII data.
Yeah.
I do think technology will help us in some of these cases too.
Yeah. How do you think AutoML is going to start? Because you had some big announcements, tables, and there's a whole market surrounding AutoML with some other vendors as well. I mean, a lot of the data science communities kind of looked at that and said, oh, well, that's not really going to work. But now it's becoming more accepted by data scientists. I mean, do you think that's going to dramatically accelerate the development of models?
I think it's going to help, and what we're seeing is it's a faster entry ramp for folks to start using machine learning. What I'm excited about is it is part of the just making folks more productive. The number of hours, both of my time and then tens of hours of compute time I've used on tweaking parameters here and there.
Yeah.
That's not what gets me out of bed in the morning. It's the actual results.
Yeah.
So AutoML, I think, is the first and by far the most computationally efficient approach to automating the drudgery away from that.
Yeah.
But we certainly, as you probably have seen, we're certainly also investing heavily in the platform for people to deploy models, such as the Cruise folks, which have been very carefully curated, because that, for many of these applications, is going to be super important.
Yeah, at Forrester, we actually identify 3 segments of machine learning solutions. One we call multimodal. So those are like some of your open source, like KNIME, RapidMiner, some of that. So there's more traditional tools that have drag and drop. And then we have notebook-based, which is oftentimes they're centered around a Jupyter notebook. But then we added this 3rd segment last year called AutoML, because you guys are doing it. You've got Data Robot, H2O driverless AI, and there's actually a handful of other vendors as well. So, but our conclusion in talking to enterprises is that one's not going to replace the other. That there's really a use case for all 3 of those in an organization.
Very good.
Yeah.
One thing that your presentation brings up is that we're not in a stable state with the AI industry.
Right.
And for folks who are like starting out in the industry, I often get questions, am I safe to be a data scientist, or is that job going to go in 3 years? Should I be focusing on the math? Should I be focusing on the computer science or the consulting? Are you able to start to envision trends in where the big careers are going to be moving towards as we evolve?
Well, I mean, if you're a data scientist, I said take your pick, because there's going to be even more opportunities in all of those things. And the math, the research, I know, when you presented, you were talking about things we can do today.
Yes.
But there's lots of exciting stuff coming. I mean, there's different forms. There's reinforcement learning that most enterprises are not doing.
Yep.
There's generative adversarial networks that most enterprises aren't doing. So there's a lot of opportunity just on the basic research or on the algorithm development front. But we believe at Forrester that most companies are doing half a dozen models. That's it, right? But we believe, and actually I have a report coming out later this year called the 1,000 Model Vision, where a large corporation will literally have 1,000 models, use cases.
Of course.
I don't mean 1,000 models of one use case, but 1,000 use cases embedded in most processes. Now, some of those they're going to buy. You know, if they're an SAP shop, SAP is working towards building machine learning in their processes.
Yep.
If it's an Oracle shop, so the application companies are doing this as well. So it's going to be build, buy. It's going to be both of those. So I think the opportunities for developers and data scientists exist. I do think, though, AutoML creates a lot of opportunities for software developers who are used to writing code.
Yep.
But now with AutoML, they don't have to understand the gory details, and they don't have to keep up with every algorithm, with how to tune every single algorithm, right? Just run them all.
Yes.
You know, there's something to be said about feature engineering too, because that's another important thing. And AutoML automates feature engineering as well. So there's a lot of opportunity for a lot of people on this.
Yes. And in fact, as the months go by, I think you're going to see more and more automation in AutoML when it comes to these questions of how you can deal with missing data automatically, how you can deal with something which is a text string, but it looks like it's referring to a geographical location, or many of these other things. It really is about taking the dreariness out of doing the exciting machine learning.
Yeah.
Well, with that, I want to thank not only Mike, but also Jay and PD for an excellent summary of what's going on in the world of AI deployment. I want to thank everyone here for coming along, and I certainly will be hanging around afterwards if anyone wants to follow up on any of these discussions. Thank you very much.